Hello guys, welcome to another video in civic engineering. And today we are going to be treating a topic on how to solve ordinary differential equation. In our previous videos, we taught on introduction of ordinary differential equation and formation of ordinary differential equation. And today we are going to treat how to solve ordinary differential equation. So whenever you are given an ordinary differential equation, what should come to your mind first is shell, SHEL, where S means separation of variables, H means homogeneous, E means exact, and L means linear. So whenever you are given any ordinary differential equation and you are told to find the general solution to that ordinary differential equation or to solve the ordinary differential equation, what should come to your mind is shell. So what means that you check whether equation can be solved using separation of variables, that is x and y. If x and y can be separated, you check if the equation is homogeneous, you solve it using the homogeneous method. If the ordinary differential equation is exact, you check if it is exact, you solve it using the exact method. You check if the equation is linear, ordinary differential equation. If the ordinary differential equation is linear, you solve it using the linear method. So whenever you are given any ordinary differential equation, what should come to your mind is shell. So you check first if the equation cannot be separated, like if the variables cannot be separated, the x and y cannot be separated, then you leave the separation of variable. If the equation is not homogeneous, then you leave the homogeneous method. If it is exact, then you solve. If it's not exact, definitely it's going to be linear, then you solve using the linear method. In today's video, we're going to be treating on how to solve ordinary differential equation using the separation of variables. So let's say, for example, you are given an equation dy over dx is equals to f of x and y. So to solve using the separation of variables, what you simply do is to separate the x and y variable. So dy over dx is equals to f of x and f of x multiplied. This dot means multiply with g of y. To do this, the method is, when solving with the method of separation of variables, what you simply do is to move all the variables of y, all the coefficients of y and dy on the left hand side. That is, make sure dy and all the gy of y are on the left hand side. Then make sure dx and all of the x are on the right hand side. So to do this, what you simply do is multiply both sides by dx, divide both sides by g of y. So what do we mean? You say you multiply both sides by dx, so dx multiplied with this side multiply with this side. So you multiply both sides by dx, then you divide both sides by g of y. So this g of y will cancel this g of y, this ds will cancel this ds. We now have only dy over g of y, which is equals to f of x dx. The next step is to integrate. You integrate both sides. Whatever you get from the integration of both sides is the general solution to the ordinary differential equation, that you have successfully solved the ordinary differential equation. Our sole aim in doing this, our first aim is to separate the variables. After separating, multiply both sides by dx and divide both sides by g of y. What our aim here is to make sure dy and g of y are on the left hand side, while f of x and dx are on the right hand side. Then after successful separation of the variables and moving all the dy and g of y on the left hand side and f of x and dx on the right hand side, then integrate both sides. Whatever you get will be the general solution to the ordinary differential equation. You can still do it this way. Let's say you are given dy over dx. This is an ordinary differential equation. Dy over dx, f of x and y. So you separate it. Dy over dx is equals to f of x multiplied by g of y. What you simply do here is very simple. What you need to do is, you see, our aim is to make sure g of y and d of y stays on the left hand side, while dx and f of x stays on the right hand side. So instead of doing the dx multiplying both sides and g of y dividing both sides, what you simply do is just g of y is multiplying on the right hand side. Look, g of y, this is the g of y, is multiplying f of x. It is g of y is multiplying on the right hand side. Once you move it over to the left hand side, it's going to divide because it is multiplying on the right hand side. Once it crosses over this equal sign, crosses over to the left hand side, it's going to divide. So you have dy over g of y, which is equals to f of x. Dx is dividing on the left hand side. Dx, dy over dx. Dx is dividing on the left hand side. Once it crosses over to the right hand side, it's going to multiply. Look, dx is dividing on the left hand side. It's dividing on the left hand side. Once it crosses over, it's going to multiply. So you have f of x multiply with dx. Then integrate both sides. After integration of both sides, whatever you get will be the general solution to this ordinary differential equation. You can see this and this are the same thing. You just choose the one that is easier for you to understand and solve. So let's take examples on separation of variables. Let's take examples of ordinary differential equation that can be solved using separation of variables. Okay, let's solve this ordinary differential equation and see if we can solve it using separation of variables. Let's go to example number 1. Example number 1 says dy over dx is equals to 2x over y plus 1. If you look at this equation, it can be solved using separation of variables because y plus 1, the variable of y plus 1 is separate from variable of x. So in order to solve this equation, what you simply do is to move variable of y, to move the variable of y and dy on the left hand side and make sure dx and f of x are on the right hand side. So to do it, you say y plus 1 is dividing on the right hand side. You see 2x over y plus 1. Y plus 1 is dividing on the right hand side. So once it crosses over to the left hand side, it's going to do what? It's going to multiply. It's dividing on the right hand side. Once it crosses over to the left hand side, it's going to multiply. So you have y plus 1 dy. Once it's dividing on the right hand side. Once it crosses over to the left hand side, it's going to multiply. So y plus 1 multiplied with dy is equals to, you put down your 2x. Dx is dividing on the left hand side. Is dividing on the left hand side. Once it crosses over to the right hand side, it's going to multiply. So you have 2x multiplied with dx. Then integrate both sides. Integrating y, the power will increase. There is a spiritual 1. Y is raised to power of 1. There is a spiritual 1. And every number is raised to power of 1. There is a spiritual 1. Every number is raised to. So, and integrating, there are a lot of general form of integration. The power is going to increase. So you're going to have y raised to power 1 plus 1 all over 1 plus 1, which is going to give us y squared over 2 plus, if you integrate 1 with respect to y, you're going to have y. If you integrate 1 with respect to dy, if you integrate 1 with respect to y, you're going to have y. Y squared over 2 plus y is equals to, if you integrate 2x, you're going to have 2x squared over 2 plus our constant of integration. So we have y squared over 2 plus y equals to 2x squared over 2 plus c. This 2 is going to cancel this 2. So we'll be left with y squared over 2 plus y is equals to x squared plus c. If you look closely, we need to clear this fraction, y squared over 2. So we multiply both sides with 2. So if you multiply everything here with 2, you multiply everything here with 2. Therefore, we are going to have, if you multiply everything here with 2 and multiply everything here with 2, these 2 will cancel the 2 up here. So you're going to have y squared plus 2y is equals to 2x squared plus 2 times c is still the same thing with a constant, which is c. We don't know what that constant is, so we say plus c. Therefore, we say this is the general solution to this ordinary differential equation. You'll see it can be solved using the separation of variables because we can simply put the y and variables of y on the left hand side and dx and the variables of x on the right hand side. So moving over to example number 2, dy over dx is equals to 1 plus x, 1 plus y. You look at this equation, yes, it can be solved with separation of variables because the variables can be separated. So to separate this variable, we simply do it our normal way. dy 1 plus y is multiplying on the right hand side. 1 plus y is multiplying on the right hand side. Once it crosses over to the left hand side, it's going to divide. So we have the y over 1 plus y, which is equals to 1 plus x. 1 plus x, put it down. Dx is dividing on the left hand side. Dx is dividing on the left hand side. Once it crosses over to the right hand side, it is going to multiply. So we have 1 plus x multiply with dx. Then integrate both sides. You know, this is the same thing as 1 over 1 plus y. That is, this is the same thing as integrating 1 over 1 plus y with respect to the y, with respect to y. This is the same thing as this thing here is the same thing as this. Integration of 1 over 1 plus y with respect to y. So if you integrate 1 over 1 plus y, you're going to have the natural log of the absolute value of 1 plus y, which is equals to, if you integrate 1 with respect to x, you're going to have x, plus if you integrate x, you're going to have x squared over 2, plus our constant of integration. Therefore, we say this is the general solution to this ordinary differential equation. So moving over to example number 3. Example number 3 says dy over dx is equals to 1 plus y over 2 plus x. If you look at this equation, yes, it can be solved using the separation of variables. And to do this, we simply do it our normal way. 1 plus y is multiplying on the right hand side. 1 plus y is multiplying on the right hand side. Once it crosses over to the left hand side, it's going to divide. It's multiplying on the right hand side. Once it crosses over to the left hand side, it's going to divide. So you have dy over 1 plus y is equals to 1 over 2 plus x. Dx is dividing on the left hand side. Once it crosses over to the right hand side, it's going to do what? It's going to multiply. So multiplying with dx, integrating both sides. Integrating 1 over 1 plus y with respect to dy will give you the natural log of the absolute value of 1 plus y, which is equals to, if you integrate this, to integrate this, what you simply do, to integrate this, 1 over 2 plus x. Integrating 1 over 2 plus x will give you natural log of the absolute value of 2 plus x, plus our constant of integration, c. We can still say natural log of the absolute value of our constant, because our constant, we don't know what it is, so we can put it that way and it will still be the same thing, so that we can factor out the natural log to cancel it on the both left and the right hand side. So we can still say natural log of the absolute value of our constant, which is c. So we still have natural log of the absolute value of 1 plus y is equals to, since there is natural log of here, there is natural log here, so we can factor out natural log. We say natural log of our c multiplied with natural log of c multiplied with absolute value of 2 plus x. Therefore, this natural log is going to cancel this. We now have 1 plus y is equals to c multiplied with 2 plus x. Therefore, we say this is the solution, this is the general solution to this ordinary differential equation. So guys, if you are getting value from this video, consider giving us a like, subscribe, turn on all the notification bell in order to get notified whenever we drop a new video. And please share this video to all your friends who might find it difficult in understanding how to solve ordinary differential equation using the separation of variables. And please, if you have any question or there is any part in this video you don't understand, drop into the comment section so I'll answer your question as quickly as possible. Thank you.